Hi guys, welcome to this video. We are just going to be going through a pack of past exam questions right now. This was put together by Maths Genie. Do make sure you are using that as it is such a good resource. They look at loads of past questions from the past 7-8 years, and it's a really useful tool for your revision. So this is actually kind of follows on quite nicely from the very last video, which you will have watched. Where you are asked to sketch a graph of y equals tan x. So remember what I said in my previous video, that it would be good just to draw a table just to help you imagine what the shape would look like. Now you do need to remember tan x has got that odd shape. Okay, it's for one where they're kind of disjoint lines, they're not joined up, and they have those values that are undefined, that are infinitely big. So what you would just need to do is similar thing, draw out a table, x and tan x, and just choose some values. So let's go 0, 45, 90, 135, 180. We'll leave it there because there will be a real pattern you will be able to spot. So draw my lines in. Let's go with tan of 0, that's 0. So that is going to be a point that I want to plot. Tan of 45 is 1. Tan of 90, I get math error. That means it's infinitely big. Okay, so I'm just going to put an NA in there. Right, let's try tan 135. That's minus 1. Tan 180 is 0. Go a little bit further actually. Tan 225 is 1. And tan 270, again I get a math error. So actually that would carry on going, that pattern would continue forever and ever. Every 45 degrees I go 0, 1, infinite, minus 1, 0, 1, infinite. The next one would be minus 1, 0, 1, infinite. Okay? So the very first thing you ought to do is just plot on those weird looking dash lines where they're infinitely big. Okay, the posh mathematical name for those are asymptotes. It just means, sorry guys, it just means that the value, so your graph never actually reaches a defined point. It's just so big it never actually reaches it. So I'm just going to draw those in. My asymptotes, and there's actually going to be no other ones. You can see it jumps up by 180 degrees. The next one would appear at 450 degrees. So I know that when x is 0, tan of x is 0. I've already plotted that. When x is 45, I have tan 45 is 1. And then when tan of 90 is infinitely big. Okay, so it would reach up. It would go very rapidly up. Actually, if I just demonstrate a few numbers, let's go for tan 60. I get 1.73. Tan 70, 2.74. Tan 80, 5.67. Tan 85 is 11. Tan 86, 14. So you can see I'm taking smaller steps each time, but it's rapidly getting bigger and bigger. I'm already into the 50s. 89.9 is in the hundreds. 89.99 is in the thousands. It's getting closer and closer to infinity. It's only going up by a little bit each time. So the shape that this would take would be something like this. Remember, it's only a rough sketch. Okay, tan of 135 is minus 1, so it's going to be about there. Tan of 180 is 0. Tan of 225 is 1, and then I've got my asymptotes here and here. So that pattern would continue. It would be infinitely small here, or a negative infinite there, and then it would take this shape. Okay, not a very good one, but it would pick up marks. And then you are just going to do a similar thing here. Okay. So that is the shape of it. That's one of those where you will probably remember it visually rather than actually the maths behind it. Okay, what we're going to do is just whiz through some of these questions. I'm going to talk through my thought process when I'm answering them. So this is actually quite similar to what I think you would have done in your mocks, in your winter mocks. We need to match up the four graphs with their equations. So we've got y equals, just move that down, we've got y equals sine x, y equals 2 to the power of x, y equals x cubed, y equals cos x. Now, first one I'm going to look at is y equals, actually let's just think about y equals sine x. So straight away there's a couple I can rule out. I know it's got that ever repeating wave motion, so it's definitely not going to be C, it's definitely not going to be B, it's going to be one of these two, but how do I work out which is which? So I can see that when x is 0, this one is 0, when x is 0 here, this one is going to be 1. So which one of those, which one of sine and cos, when it's 0, gives me 0. So sine 0 is 0, this graph, when x is 0, y is 0, so it means that this is y equals sine x. So this is letter A. Okay, by default then, I know that that is going to be D. Because again, I've got that shape. When x is 0, it's going to be, let's just go on my calculator, cos 0 is 1. Okay, so I can see it starts off high up there. So that is going to be cos of x. Right, now I've got y equals x cubed, so a cubic, and y equals 2 to the power of x. Now, exponential graphs, they have not been mentioned in the advanced information to my knowledge, so I would be surprised if this did come up. But really, you could just play around with some numbers. Okay, so I can see two differences here. When my x is negative, it's a very small positive number. Here, when my x is negative, it's quite a big, it's getting an increasingly big negative number. So what I'm going to do is just sub in, let's just say that is minus 10. Let's work out what minus 10 cubed would be, and let's work out what 2 to the power of minus 10 would be. So I'm just going to type that into my calculator. So minus 10 cubed gives me minus 1000, and then 2 to the power of minus 10 gives me, well, 1 over 1024. That's going to be quite a small decimal, but it is positive. So that means that this must be the one with the power of x. So this one is going to be y equals 2 to the power of x, which means this one is y equals x cubed. Okay, that was my thought process behind it. I'll just show you the answers there and the questions. Okay, moving on to this one. Here's a sketch of the curve y equals sine x for 0 is less than or equal to x is less than or equal to 360. Given that sine 30 equals 1/2, write down the value of sine 150 and sine 330. Now, this would probably be unlikely to come up given that your next two exams are calculator exams, because all I could do is type in sine 150 and get 1/2, or sine 330 and get minus 1/2, and move on to the next question. But if it is showing you a sketch, it wants you to specifically reference that. So what you do need to remember is the fact about the symmetry in these graphs. So I know, let's just mark on roughly where sine 30 would be. I know that sine 30 is 1/2. Now I know that is going to repeat. If I go across, I can see that it's about half here. If I draw a line across, it repeats about here. So I need to know roughly what that will be. Now remember, this is symmetrical. So if I go 30 in from my start point, the y value will be 1/2. So if I go 30 in from my end point, my value will be 1/2, and 30 in from my end point is 150. So sine 150 is 1/2. Now what about sine 330? Well, there is also some symmetry here. So sine 330, the first thing I'm noticing is that it is 30 away from 360. Now I know that little bit of distance there is 1/2. So you can see that this has just been flipped upside down. So this would make this minus 1/2. Okay, like I said, I think that's probably quite likely to come up in the 2022 series of papers, given that it is calculator, but it is just an important skill to have, being able to read trig graphs. Here is a sketch of the curve y equals cos x for 0 is less than or equal to x is less than or equal to 360 degrees. Use the graph to find estimates of the solutions in the interval 0 is less than or equal to x is less than or equal to 360. Now, it's important that you do use the graph here. They'll be looking, your examiner will be looking for you to have read across and read the values. So it wants to know what x value gives you minus 0.4 in this interval. So let's just think, where would minus 0.4 be? So there are 10 squares between 0 and minus 0.5. So that means that each little square is worth 0.05. So minus 0.4 would be here. I'm going to draw a line across from here. Just get that nicely lined up. So I can see I'm going to have a value here that when I plug it into my equation gives me minus 0.4. When I plug it into cos x, gives me minus 0.4, and a value here. Now let's think what those values will be. Well, each little square, what's that going to be worth? So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares between 60 and 120. So each little square is worth 6. So I'm 1 square away from 120. So that value there will be 114 degrees. And here I'm 1 little square on from 240. So that value will be 246. Let's just check that on my calculator. Cos 114 gives me minus 0.40. This has just been rounded, and then 246 again gives me very close to minus 0.4. So remember, it is only an estimate. You're doing it visually. It's not going to be exactly that, but you do need to make sure you're using the graph. Okay, this one, 4 times cos x equals 3. Now, straight away we see an issue. My maximum values of y are 1 and minus 1. There's no way I can draw across a line from 3. So instead of thinking about 4 times cos x equaling 3, I can make cos x the subject. Cos x equals, well, how have I got rid of that 4? I've divided by 4. Cos x equals 3/4. So I'm going to draw in a line at 3/4, 0.75. And you can see again, oh, that's a terrible line, sorry. You can see, again, I've got 2 values. So I've got a value here, and I've got a value here. So that is about 1 little square on from 30. So that's going to be 6 degrees on from 30, or 36 degrees. And this one here, well, I've got 300, 360. That means that this line represents 330, and it's 6 degrees before there. So 324 degrees. Okay, so that would be how you would approach that question. Make sure you are making reference to the graph. Don't just use your calculator, because it will not show you all the values. Okay, now this is a pretty horrible question. The depth of water, d meters, at the entrance to a harbour is given by the formula d equals 5 minus 4 sine 30t, where t is time in hours, after midnight on one day. On the axes below, draw the graph of d against t for t between 0 and 12. Now that looks absolutely horrible, I'm not going to lie. But if I just cast your mind back to how I originally sketched my sine graph, my cosine graph, I just used a table, much like I did for, let me just get it, if we look here, much like I would for plotting a straight line graph or a quadratic curve. Okay, I would simply use a table, and that's what I'm going to do here. So I've got my t along the bottom and my d up the side. So t, remember, would just be my x, d would be my y. So if you remember what I did here, I plotted my x and my y. So here, that is going to be t and d. And I'm going to write down, should I say, the values from 0 up to 12. Oh, not straight away getting to 12. 0, 1, 2. Okay, so what I'm going to be doing here is taking this horrible looking formula I've got here, d equals 5 minus 4 sine 30t, and I'm just going to be plugging in my different values of t. So I'm just going to set my calculator up in a way that's going to make it nice to do these multiple values. So I've got 5 minus 4 times sine 30 times something. So first of all, it's going to be 30 times 0. So I'm going to type that in, and it gives me an answer of 5. Now I'm going to try 30 times 1, gives me an answer of 3. 30 times 2, oh, first horrible answer we've got, 1.535. When t is 3, my answer is 1. When it's 4, it's that number again. We can see the symmetry which I mentioned earlier on. When t is 5, it's 3. When t is 6, it's 5. When t is 7, it's 7. When t is 8, it's 8.46. When t is 9, it's 9. When t is 10, it's 8.46. When t is 11, it's 7. And when t is 12, it's 5. So again, if I just look at two of these parts in isolation, I've got some symmetry there. 5, 7, 8 point something, 9, 8 point something, 7, 5. I've also got symmetry here. 5, 3, 1.35, 1, 1.53, 3, 5. Okay, so all I have to do is plot those values. So when t is 0, d is 5. When t is 1, d is 3. When t is 2, d is 1.5-ish. Let's just plot it there. When t is 3, d is 1. When t is 4, it's that horrible value again, 1.5-ish. When t is 5, it's 3. So you can see that symmetry emerging already. Just plotting these values as I got from up here. When t is 7, d is 7. When t is 8, d is 8.5-ish, so about there. When t is 9, d is 9. When t is 10, I've got that horrible 8.46 something again, which is about there. When t is 11, d is 7. And when t is 12, d is 5. So whilst it's not a sine graph, it's still got that shape, it's got that symmetry because we've got sine in the function. So what I'm going to do is just join that with a smooth curve Remember, use a pencil because if you make a mistake, you can rub it out later. Okay, so that is showing you the depth at varying times in the day. And then question part B, which you'd expect from these questions, find the two values of t where t is between 0 and 24 when the depth is least. So you need to be thinking about the properties of a sine graph here. I mentioned it goes on forever. I've got my start point and my end point, which are the same. Now if I went on by another hour, I'd get 3. So 1 hour after 12, the depth would be 3. 1 hour after 0, the depth is 3. Let's go 2 hours after 12. The depth is 1.53. 2 hours after 0, the depth is 1.53. So that is going to keep repeating. Okay, the cycle, or the period of that wave, that's a technical name for it, is going to be 12 hours. It repeats every 12 hours. So the two values of t, where the depth is least, well, I can see the depth is smallest here, after 3 hours. 3 hours into the cycle, it's at its lowest. So I already know that one, I can see that visually. But when will it next reach that lowest point? Well, it's going to be another 3 hours after it's gone to its original depth. So another 3 hours on from 12, so that is going to be 15. Okay, so that is a really hard question. It's quite a horrible graph you have to draw, but there are marks there to be earned. Okay, there's going to be one more video looking at sine and cos graphs and some of the things you could do with them, but it is going to be some really hard stuff that it could be, but it's almost impossible to answer, but it is worth looking at. So I hope this has been helpful, guys. Do let me know if you've got any queries.